So before you disappear, I should tell you, or even we start asking people questions, there are some refreshments out the back of the hall in the second floor of the ICT. So if you go out the back, you can get refreshments. You're all welcome to that. I have one question for you, Richard. How old was Turing when he did this?
Well, 35 minus 12, 23.
He was an undergraduate
Yeah.
at the time. So
well, he was a fellow at King's College, Cambridge, right? So that's not just being
not quite the same. Yeah. But he hadn't done his PhD.
But people didn't do PhDs then.
Oh, well, they didn't do, okay. Yeah. But he was very young. So, are there any questions for Richard?
Why did Turing suppose that this tape was infinite from the start? I mean, it does not have to do with the fact that he was starting with real numbers that went on for
Why did Turing machines have an infinite tape?
Yes.
Well, yes, you're right. So in the first instance, because Turing was interested in computable numbers, and for a number, right? So for the range of computable numbers to even approximate, right, the range of real numbers, you need an infinite tape because the real numbers have infinite binary expansions. But the second reason is, well, if the tape is finite, then we can only compute finitely many things, right? So I guess perhaps what you're getting at is that, well, in actual computers, the storage space is limited, right? But what Turing was trying, what you do, I suppose people didn't realize this at the time, right? But one way of what you don't want to do is you don't want to limit what turns out to be computable with something as arbitrary as how many gigabytes of storage you have, right? Let's just say, well, if it turns out that we need more than the 1 terabyte that I have, right? Just add another tape, right? So it's not. So in that sense, I guess another possible way of answering your question is, it's not important for Turing machines that the tape is infinite, right? The only thing that's important is that it can always be extended if needed.
Hello?
Oh, sure.
Yeah. So Gödel's work took place at about the same time, in the early 30s. Was there much interrelation between the two things? Because there seemed to be some similarities.
Yes, of course. So the Turing was sort of got to thinking about these things by I think he was actually taking a seminar with Max Newman on the foundations of mathematics, and they were studying Gödel's papers on the incompleteness of arithmetic, and I suppose at the time they would have been studying Hilbert and Ackermann's textbook on the foundations of logic, and in 1934 the foundations of mathematics by Hilbert and Bernays also appeared. I don't know if they were studying that. But Turing was definitely aware of Gödel's work. In fact, it was cited on the very first page of the paper. He also, I don't know if he knew about Gödel's work on general recursivity. Perhaps not at the time that he was writing that paper, but definitely when he was in Princeton, because Gödel did that while Gödel was in Princeton in 1934.
Refreshments Okay, well, we should thank Richard one more time.